I'm going to talk on Libre designs in the software apocalypse, and enough of that. So let's turn the hyperbole down from 11, and let's get away from the terrible AI-generated imagery. That was partly added in there because Eliel's talk was going to be before mine. I thought, okay, please describe the Libre designs in the software apocalypse, and that was what we got. Great. So what I wanted to talk about was graphic design and user experience in open source programming tools and tools for programmers. So a little bit about me, because I think partly this is about who I am, but also it's a little bit the context I'm coming from. So I work as a Java developer. You can commiserate with me later. But primarily working on open source things around real-time systems, real-time programming, media, and tooling. But my background is in fine art and music. So I was building interactive projections and things like that. Somewhat a lapsed live coder. If you're in Seville, you might have seen me doing some live coding. And there was a possibility that I was going to be doing some tomorrow, but unfortunately that's not happening. But the live coding aspect is a sort of key part of what I do. And I'm developer of Praxis Live, which is a hybrid visual interactive environment for doing graphic, audio, and creative coding, as well as somewhat more of a focus on general purpose coding recently. And somehow got involved about 7 years ago, because Praxis Live is based on top of the NetBeans platform. I'm now one of the key maintainers and work on the release team for the Apache NetBeans IDE. So I am working on programming tools. So background to this talk. Two things that kind of this talk comes from. One was we had a bunch of sessions in LGM in 2019 that were around improving design and the user experience in floss tools and the tools, graphic design tools and artist tools that people are using, and the encouraging Libre designers to contribute back into that process. And that got me thinking about, well, I'm starting to work a lot more on programming tools. How do we bring that pipeline even further back? How do we get these people, encourage these people to work with us on improving this aspect in coding tools? And the second thing, where the software apocalypse title comes from, there was an article in The Atlantic in September 2017, so quite a long time ago now, talking about the ubiquity of software replacing systems that used to be mechanical. So, we're getting used to the fact that a software bug might accidentally lose your work. But the fact that we're having problems with software faults taking down the entire state's 911 system for 8 hours, where it would not work. This was caused by an int overflow that had been kind of ignored, and the pathways that were meant to pick up the error didn't work. Or you've got cars that had a computer-controlled acceleration system, and key times they had uncontrolled acceleration. So this quote's from the Coming Software Apocalypse article. And it was partly talking about the testing system, but also this kind of stuck out to me. Software doesn't break. So a faulty threshold is not like the faulty rivet that leads to the crash of an airliner. The software did exactly what it was told to do. In fact, it did it perfectly. The reason it failed is it was told to do the wrong thing. Software failures are failures of understanding and of imagination. And that was kind of the thing that was picking out here. There's a design aspect to this. So I proposed this talk for LGM in 2020, and we had other bug story about that year. And I was sort of thinking about the theme for this as reimagination. Do I want to revisit this talk and come back into it? And I was thinking, is it still relevant? And to me, it seems very relevant still. The article seems very relevant still. And then it's like, well, AI code generation. Actually, what AI code generation potentially do is bring in more complexity that no one understands. It's, in a way, the problem is understanding what the code in front of us is doing. And so it's a way of looking into that. So personal view. But generally, I think most programming tools are terrible for this. Some are less terrible than others, perhaps. I might have biases, but they're generally not great at this. So apologies for going from that poo emoji directly into a quote about a Microsoft Visual Studio. But this is a problem, I think, if you did the same thing with the NetBeans project I'm involved in, you'd probably come with the same issue. 55 million lines of code. They did a usability study on Visual Studio. I think they ran for 6-8 weeks or something, I can't remember. This is also quoted in that article. And they found that 98% of it was completely irrelevant. So all this work had been put into building this tool, but it missed the fundamental problem that people faced. Basically, people are playing computer inside their head. Now, I will caveat slightly. So one thing I've noticed working on an IDE is, I can completely believe that the vast majority of people are not using the vast majority of features. But someone probably somewhere is. And so that is also one of the issues. So you can't kind of talk about this topic without mentioning maybe someone like Brett Victor in Inventing on Principle in Dynamic Land, and that's something that actually is picked up on that article. And maybe people like Ink and Switch who are making various experimentations in this. Now, I've mentioned them, and that's as far as I'm going to go there. The reason is I think a lot of you have probably come across them. If you haven't, please do explore. But also, I think what interests me most is, if you're seeing these things as a place we might get to, the Z at the end of our A, what interests me more is B and C and D. What are the steps we can do to improve tools now in terms of design? So, the key thing is how we usually work with code. It's, in a way it could be seen as using typography. You've got syntax highlighting, semantic highlighting. This is for NetBeans, but most code editors are quite similar. You're using coloring to go simple bits of information. There's a little bit of semantic analysis going on. So it's picked up that some code is unused, so it's put a little light bulb there. It's swiggled in yellow underneath. The method, the goodbye method, is not used, so it's squiggled again. But there's very little, really, information about how the code is behaving. In terms of extra information, then, how do we bring that into that environment? One thing we had it in NetBeans that a lot of code editors added is inline hints. And this was to bring things like type in, parameter names, that sort of thing. And this kind of was a bit awkward to use, because suddenly you broke up the natural way that the cursor moves across text. Suddenly, bits of text were coming in out of sync that you couldn't edit. We enabled it by default for a couple of releases, and we got so many complaints, we disabled it by default. We found we weren't using it ourselves, and that was generally, I think, a good principle for small projects, small development teams, is at least work with the defaults and see if they make sense to you. So there's a limit there, and obviously you've got other things where you'd bring things on top of the text and you'd show extra information. Now, this is processing's tweak mode, which is a little bit like Brett Victor's ideas of inventing on principle, where you can actually, you have to imagine the mouse pointer here. For some reason, Gnome Screencast was not picking up the mouse as I was doing this. But you've the ability to immediately edit a value in the code and to see its effect on the output. There's also another thing which is slightly related to that, was you've got this color annotation where you know a type is a color, you see that in the editor. Problem with this sort of thing is it doesn't really scale well. It's a great tool for beginners learning how to program, how something interacts. It's also not really picking up anything about the behavior of the code that's running. So it's all about the user changing, but not what's going behind. So, like I said, I've done bits of live coding in the past. One system I liked when I saw Gibber by Charlie Roberts. Now, it can do some visuals, but this is from an audio form. But you can, again, see annotations that are actually a feedback relationship, where you have a system that knows what the behavior is and is actually representing it, not only to the coder, but obviously in the live coding situation, to the audience, what is happening. The other thing I like about this primarily is that it does not break up the text position, cursor position. It feels natural. It's not using text, which kind of changes your relationship about what you're reading. So a lot of it is graphical around the text or waveforms. Of course, there are limits to what we can do with just text alone and the view on the text alone. Unless perhaps we started looking at beyond our 80 characters of code and started looking in multiple dimensions. So this is plan calcul. This is one of two examples in this talk that are not open source, and that's because it massively predates open source. This is from the 1940s, and it's one of the first examples of a high-level programming language. But really, we're stuck with the code we have, and we're stuck with this very limited thing. So, most of the time we're working with code, we have a very limited view on that code. It's like working with a bitmap, where you can see minuscule pixels within the overall context. Also, one of those pixels might be in a file somewhere else. One of them might change another pixel somewhere else. Yeah, these interactions are not represented in the code. So zooming out. So it seems that many people may know this photograph already. This is Margaret Hamilton. She led the software development engineering team for the Apollo moon landings, and also is credited with coining the term software engineering. This is a printout of the source code for the Apollo moon landing. I was trying to find a definitive answer of how many lines of code was in this, and there doesn't seem to be any definitive answer. One answer is 150,000, which amused me because that was what had been inherited in the processing talk the other day. So that's what you're dealing with. Potentially there's a lot more there, but the point is there's a huge amount of text to try and make sense of that you will never read all of, you'll never understand all of, and you're trying to picture these relationships. So, if it's not text, what is it? Practice live, node ride. I like node environments. I don't think they're the answer. They are a good answer for a narrow subset of things. So we can, they're good for modeling data flow. They're good for modeling behavior graphs, as we saw today. They tend to get complicated when you're looking at data that's going in multiple pipelines. You're looking at recursion and that sort of thing. In terms of modeling the entirety of software behavior, then this is the usual situation. Now, there is one project. This is the one that's on the more commercial side of the open source spectrum of things that I've taken an interest in or are influencing me. Should have said that, actually. A lot of these projects, there's a big aspect, a whole massive range of projects that are looking at it. The ones I'm kind of concentrating on, the ones that are influencing me at the moment. And so ENSO is a open source tool that is kind of having this dual syntax between graphical syntax and text syntax. So everything is mapped one-to-one. It is primarily aimed at doing data visualization. So it's not necessarily got all the issues we might have. Data analysis, not just data visualization. But it does not necessarily have all the issues we might have trying to represent any sort of code. It's quite an interesting project. So if we're talking data analysis, then computational notebooks comes up. This is something that I kind of ignored slightly, in a sense, for a number of reasons. And partly that, in a way, they feel like that is their output. So the next system, I was watching a talk by Jack Rusher called Stop Writing Dead Programs. And obviously, my other big interest is in liveness and the fact that I basically think programming should be a live and interactive experience. Every system should support that. So I entirely agree with the general premise of his talk. I do recommend watching it. But one project he's working on, and as mentioned in this talk, is a notebook base for Clojure, which is a Lisp-like language on the JVM. What I like about this system is the fact that it's local first, it's running your system, and it's bring your own editor. Yeah, you're using a file, Clojure code, and yes, it's using the browser's representation, but you've got a continuous live representation and data flow back and forth. So yeah, bring your own editor, because programmers are very famously not fickle about exactly what editor they use. I found this example that was listed there, which is OSC spirograph. So you're seeing this back and forth where you can examine or take input on the code side and represent it in different ways. But then you can also export as static HTML. So what I like, and also came up in the Open RNDR talk, but this is actually Clojure 2D's color space library, and their documentation is an output. So this is not what the code should do, this is what the code does do. And then, so there are a number of things with Praxis Live that have influenced Praxis Live. One of them is trying to make Java more like Erlang or Elixir, which is a language that runs on the Erlang VM, where it has this notion of live updating. And I thought I'd have a look at what the sort of notebook things are in that language. It seems quite more traditional in some ways than the Clojure example. But what interested me was their use cases that were listed. Communication and automation of a running system, but also just normalizing the idea of connecting to, finding out what's going on, introspecting via code and debugging live systems, finding out what's going on, and then representing them in different ways graphically that suits the system they're looking at. There was another slide I meant to add there as well, which I realized I hadn't when I was looking through here, which was the fact that there are a number of systems, obviously, that do this with terminal visualization. So you're not necessarily looking at browser visualization to do these. The key thing is context is everything to me. So what's my favorite XML editor? Oh, Inkscape. I mean, it works really well for a subset of XML. Depends what I'm trying to edit. And so you've got this idea of the tooling and the interface representing what the system is, or the data represents. Programming languages and tools are often general purpose. The programs themselves rarely are. So another project, taking a slight detour here, but another project that has influenced Praxis Live has always been about making Java more small talk. Again, interaction, introspection, graphical representation, liveness. This is not a new concept. This has been around for a long time. The 76 represents the year that this project started. But there are lots of old concepts that are regaining in different forms their significance, AI being one of them. A lot of the things that actually make up AI are ideas that have been around since the 50s and 60s. A lot of the things we use in programming languages have been around since the 50s and 60s. So I think this way of programming will possibly, I hope, see some sort of resurgence. So contemporary small talk variant is Pharaoh. I was looking at now, here the idea of being able to graphically represent what that code is doing, to introspect on it, see the relationships between things is normal. So the other system that I've been taking a real interest in recently is called Glamorous Toolkit. Now, this is built on top of Pharaoh and Rust. And this is based on the idea that every system is different. Everything you're working with is different. This is not working in the system, it's working around the system, that you can easily create thousands of tools. It comes with thousands of tools that are built in, but the idea is to normalize the idea of building specific tools for specific contexts to explore the system you're working on. So the idea of being able to combine micro tools inexpensively. So moldable development, which is what this is based on, is a way of programming through contextual tools built for each problem. The premise of moldable development is there's no single perspective on a system that is correct. So the notebooks are kind of a form of literate programming. And one of the things they say is that there is a relationship literate programming, but no literate programming considers there to be one narrative, but actually there are many. It's a way of looking in visual and interactive operators to create and consume narratives about a system. This is not just for, so the system is written in Pharo, Smalltalk, and it's customized using that language, but it is a way of looking at any software system in any language. So, yeah, for the older programmers in the room, this is the Examiner COBOL system, using the tools and relating them, looking graphically and visually and textually and interacting. And Tudor Gerber, who is one of the key people behind Glamorous Toolkit and the idea of moldable development, along with Simon Wardley, are writing an open book at the moment called Rewilding Software Engineering, which I'm just, I'm not going to say anything more about it, but I recommend, if you're interested, having a read. It's very good. So, point of this talk, I mean, these are the things that are interesting me now. They may not be the things that interest you as a designer or a developer. But if you are a graphics designer or a graphics developer, if you're looking for your next FLOSS project to contribute to, you just maybe give tools for software development a thought. Yeah, sorry. So, yeah, that's me. You can find me. Thank you.
Any questions? It's the last round of questions for today, so if you generally thought today would be the day, this is the moment. Yes.
Thank you. That was quite interesting because it's kind of the opposite of what I sometimes perceive, because when I stare at code for long, I tend to prefer code without any syntax highlighting. So basically removing all the additional, to me it sometimes is like visual noise, distracting me from the actual stuff I'm working on. And frequently I see that syntax highlighting is highlighting stuff that is the most uninteresting part of the code. Like void is highlighted because a function returns nothing, and stuff like this. So it's an interesting perspective to see. I think it's the same problem, but you're trying to solve it in the different direction. Or
I think I agree with you, actually. I mean, that was one of the things with NetBeans where we added the inline hints, and they were useful in very certain circumstances. But having them enabled all the time was very distracting. I mean, I can't work with them there, and I turn them off. Occasionally, to flick them on to see a context is useful. I think all these things have to be about optionality to start with. What has changed in how if I'd done this talk in 2020, I think it would have been more about the tools themselves. And I think I've got more interested in the things that are around. The building, making it easy to build things that allow us to work with systems. And I think that's something I'm also working on in terms of what I'm doing with Praxis Live. Is some of it is about being able to tear away some of the visualization or concentrate on specific things or do something very contextual.
Okay, any more questions? Nah, behind the column.
So yeah, this was really, really cool. One thing that I find kind of interesting about some of these systems that have this like high degree of liveness, where you can like, basically like rewrite a function and then recompile it and then see it working on, you know, using the state that's already there in the system, that they also allow a lot of, and especially with Smalltalk, this notion of sort of like composability, that you could basically take things and normally you see like software as being this sort of like binary blob that does its own thing and they're sort of autonomous on your operating system. But with the idea of Smalltalk, it was sort of like every component on your computer could talk to some other component in a certain way. But that's a very different, I would say radically different idea of how software and operating systems should work. And wouldn't that require also like a big reframing of how we design like systems on even a larger scale?
Probably. Probably for the better. I mean, they're not, that's the thing, they're not new ideas either. And I think, you know, we're finding, like with AI, like I said, some ideas somehow finding their period. And maybe it's a time to look back at some of those things and expand on them now. But yeah, I mean, I think all systems should be live and introspective. But then that Jack Rusher talk, he's talking about Elixir and Erlang, this idea of liveness in there, where you can just change the behavior of a running system or get into it and see what's happening. That's just normal there. And his view, I think I agree with, is that should be normal everywhere. It should be at least as good as that everywhere.
I was wondering have you thought of what kind of things, like making a list of things you would like to be able to see, or things you would like to change, or like, even if it's impossible currently or it doesn't exist? I'm curious.
In what context? Do you mean in a specific system or in a general system?
When you're writing software as part of the procedure, then maybe there's things which are currently not visible and you would like to see them to understand what the structure of your code or...
Structure of code is one thing, how it's interacting with anything else, what's calling into it but live as well. So a lot of this stuff you can do in a debugger, say, if you've got a live audio stream, you want to know what's going on, or any other live data stream, if you hit the debugger, you've stopped it in a sense. It's not seeing what it's doing in live behavior. It's not being able to go into a system that is broken, that is running, a production system, and say, oh, what's going wrong in that bit? And I think that's a lot of what they're looking at is contextual information. But I think it would change for every single software project or every single art project that we're working on.
Anyone? Okay, thank you then.
Okay.